So today, like the presentation name is the improving developer experience, or what we refer as a DX using design patterns. This is for like all the, I've seen like many presentations, like they are from like a moderate level to high level at the CLA level. This presentation is mostly targeted to the from the beginners level up to like a moderate, as well as people who are still thinking about like using design patterns and so on. So myself, first of all, like I'm a founder and director of the company called Grafitects, based in Bangalore. Like I said, the main objective, like we also handle the projects, but at the same time, our core objective is like a training and certification industry. I presented at the NI Week as well, CLD Summit, CLA Summit, Developer Days, and more. I have a few stints at National Instruments in India as well. Apart from that one, like I have a YouTube channel called LabVIEW Advantage where I share some of the tips and everything. And apart from that one, like I'm a founding member of one of the lab user groups in India called INLAB, or the Indian Lab User Group. So coming back into the presentation, okay. So what do we, first of all, like to explore design patterns and everything, we need to discuss about what is the developer experience. So as you can see, like for example, let's say at the moment we are struck by the COVID, and there is like a lockdown in majority of the countries all over the world. At the moment, like some of the travel restrictions are there. You cannot go anywhere, wherever you want. But at the same time, like it is seen that like in most of the places, let's say like after COVID ran out and everything, now you want to have the long vacation where you wanted to go. So in that case, what you do it is like the easiest thing, intuitive way to do it is like people go to the app download place, and then like they are going to search for the app. Let's say in this case, we're looking for the weather, whether you are using like Apple-based iPhone or like you are using Android systems or something. You go to the like App Store or Play Store and then search for that app. So once you search all these apps, like what you actually do it is, one thing is like you are going to download these apps as you go. Like you don't wait which one is good or bad or anything. You just download as it is. And one of the reasons why we download most of the apps as we go is, one of the main reason is because they're actually free. Okay, so you download all of them, and then as some of the apps are getting downloaded, you are testing other apps and everything. So as you go, like a test and everything, but at the end, like once you have downloaded, let's say like 4 or 5 apps you have downloaded in the system, you are going one after another, running and everything. Eventually, you are not going to have all these apps in your system. So what you're going to do it is like eventually you will be left out with like let's say 1 or 2 apps. Now, like how do you actually reach to that conclusion? Okay, how do you select it? So how you select is like the first thing is whether like the app is providing you the accurate information or not. Another thing is like it is clear or not, like is it easier to read. Another thing is intuitive. For example, like if I press certain things, like it should happen. Like let's say like there is a like X button, okay, but if I press the X button, something else happens. It doesn't actually make like a sense to us, because intuitively, like whenever we look into the user interface or something, many people will think that X button usually mean like a closing or stopping or something. And similarly, like it should be easy to navigate. So these are the things you are going to select. Apart from that one, like other things you can consider is like whether how fast is the app, how responsive it is. For example, like if I press it and if I have to wait for it, nowadays, like people have got like a very short attention span. So like they want everything to happen quickly. Another thing is like based on your memory sizes. For example, even if you have got like a large like a memory in your mobile device, still in that case, like you might have a lot of photos and videos in your system. So in that case, it's like because of the memory space and everything, that can be the issue. So you cannot have all the apps, or some apps might be occupying more space. And another thing that is going to consider, even if you have got app that is going to provide you the accurate information or clear, intuitive or something, at the end of the day, like most of the people will go with the aesthetics. For example, like you can look into the app, and then the app is actually showing you, let's say, temperature is such degrees centigrade or degree Fahrenheit, and it is going to give you wind speed and everything. It will give you in a tabular format, okay? Rather than that, like just like here, we can see there's a sun and a cloud. So it means like it is going to be sunny day, okay? So basically like it is going to be like a more easier for people to just, okay, I look into the app and then know it. And eventually most of the people We'll consider about the user reviews as well, and feedback and everything. And that's how like people will go through the application process. So what do we refer, like why we're talking about this is because what we have discussed earlier, that whenever a person is using the application, they are actually going to look into like simplicity. Okay, so how easy it is to use, how intuitive it is. For example, if you make some mistake, like it is still going to help you use it without any issue. You can easily learn it and navigate and everything. So basically, this is what we refer as a user experience. Okay, or in short term, like a UX, because as LabVIEW developers, our objective is to like deliver the application that the users should be able to like use it immediately. Now, like one thing we need to keep in mind is like a customer is not at all concerned about DX. We'll come into what the DX is at the moment. Okay, so basically, like we discussed, that the user or the application user was able to like download all these apps as he went through, and then he just like went through, browsed through that, and based on his experience, like how easy it was and everything, they just like go with the application itself. They don't actually concerned about like what are the challenges you faced. For example, in the work environment, let's say like you develop the application, day and night. Okay, so you have a deadline to meet and everything. You work day and night, and like a lot of time and effort is required and everything. So underneath the hood of the application, the user doesn't actually care about like how you have actually developed that application. So this is the main concern. Okay, so this is why like we'll be coming into that one. So let's look into the real world scenario now. Coming back into this one, we'll go more deeper into what the DX is. But let's say like a customer comes to you and asks you to develop an application. Now you develop the application first of all, and then deliver it to the customer. The customer is very happy. Now the next step is like let's say you started working on the other projects, and finally like eventually the customer comes back to you again, and now like the customer will ask you for certain modifications. Okay, but the main issue is like since you had worked with that project a long time ago, maybe like 5 months, 6 months, or even 1 year or 2 years or something. Now like there can be some issues. We'll look into that one in a moment. Similarly, the customer comes back to you and requests the application. This is second scenario. Customer is happy with the solution. The customer goes, but in this scenario, the same customer does not come back, but another customer comes back with the similar request. Now, since you had like worked in a project very similar to that one, you already know like how to develop that application. Okay, so the requirements may be like very similar, but with some variation and additional functionality. Okay, so the issue with this one, like this looks really good in like in the slides and everything, but the big challenge is like what actually happens is like we are all like LabVIEW users, and LabVIEW is graphical in nature, and you must have heard about like how LabVIEW is so easy. You don't need to remember about the syntax and developing the applications and everything. So it's just like developing a flowchart and everything. But like at the end of the day, like let's say a customer comes back to you and requests for the modification, or want to develop another application which is very similar to what you've built in the past. So eventually, like you will reach into this kind of scenario. Okay. So when I wrote this code, like I only got and I understood what it did. Now, like God knows. Okay. Now, like the scenario will come into the place where you will be looking into the code, and then the code will stare back to you. Okay. So this kind of scenarios can happen, and these can lead to a lot of huge issues, because you will lead into a lot of problems. Right? So let's look into like some of the scenarios. So one of the scenario, like I'll give you like a little bit of my experience while I was like consulting for National Instruments in India. So I was very closely working with some of our peers from application engineering team. So they used to receive the codes from the customers, and then most of the time when I would look at the code, like I used to cry. Okay, so because I was a CLA, and then like the potential of LabVIEW is so much, but like people are using in a haphazard way. Okay, so the one of the scenario that can come into it is like they're going to build a code, like let's say like you have a single while loop which includes all the code. Okay, or maybe like 1 or 2 loops, but it's still like got too many codes inside that one. Okay, there are certain technical terms here, but like I'm not going into that one, which is referred as high cohesiveness and everything. But at the moment, like let's look into very simple, trying to keep it as basic as possible so everybody can grasp what the DX and how to improve it. So when you write entire code into the same place, like it will become complicated. It's going to be too large code. That basically means like when you go to the LabVIEW environment, like you need to like scroll from left to right or up to down or something. The moment you scroll to the left hand side, the code on the left hand side is hidden. If you go down, the code on the top is hidden again. Okay, it's going to be very different. Another thing is like it is going to be unreusable, which basically means it is very application specific in nature. So anything that application is specific in nature cannot be reusable mostly. Like the reusable value will go down drastically. And similarly, like it is unscalable, like you can extend it very easily, and it is going to be resource intensive because like all the codes are running single iteration. So this is the first scenario. Okay. So we'll be like going through like some of the scenarios and look into what are the scenario conditions. Second scenario is like some people like they are not going to write into the same thing, but they might be using something called as like a stack sequence. Right? Stack sequence is a very good way of like running a code that is going to run in a sequence. But if you got like a large sequence of code like which is going to like go back like a forward and everything, for example, in this case, I'm showing the single frame, single like stack sequence, which is actually spanning longer. Okay, so like it is the same, like 4 of them are like actually the same frame, so in sequence. But like again, like it also suffers from the same scenarios like the previous scenario. So the code is too long, it is unorganized, we do not know like which code has to run after which one. You can actually know it, but the problem is you have a fixed sequence execution, which basically means you cannot change these steps. So whatever you have written the code in the initially, that is the way it is going to execute. You cannot do anything about it. Now the next thing is like you have a 2 parallel codes running. Okay? A lot of loops are running in parallel. Okay? So I've also like seen this kind of code, like when I receive the code from the customers, they want the code reviews and everything. So it's unreusable. First thing, again, like it is going to be very application specific. Like what we refer as the application is like they're not looking into like what are the future possibilities, or like do I need to maintain this code in the future? They don't have that thing in hindsight. So like what I'm going to do, it is like they are going to always going to like just try to fix the problem, okay, as it comes. So in that case, like adding another code on the top of each other, and it is going to like quite messy. And again, like it is going to be unscalable. And one thing is like you will not have a proper communication mechanism between the loops. Okay? They're just sending the data, and it can lead to racing conditions, memory issues, all that kind of stuff. Completely depends upon the part of the code that is posted inside each of the loops. Now the fourth scenario can actually be one of these 3, combination of all these 3. So this is going to be like a one giant problem, and this kind of code, like you can review the code initially a little bit, but it is not possible because like one time, like I received the code review request from one of the customers, and they had got like 5,000, 6,000 VRs in a project. They had like a certain deadlines, and now like it's very difficult because you cannot even sit down and rewrite the entire code as well, because like there is not enough documentation as well. But this presentation is not about the documentation aspects, readability, and but here like we're looking into how we can standardize the code so that like we can make use of it to improve the developer experience. We'll come into what is the developer experience in a moment. So now like you have run into this kind of issues and everything, like it's unmanageable and everything reusable. So these are the common challenges that we actually faced. This is in the real world scenario when you don't have a game plan for developing the application. So unreadability is the first thing we discussed already. The customer comes back to you requesting for the changes or upgrade and everything, but you do not know, okay? So like you don't even recognize the code, what it does. So it wastes a lot of time. Unreusability, like I discussed, if your code is very application specific, then like it is going to be unreusable. Unscalable, we have already discussed. You just need to throughput. You can increase or decrease. Inextensibility, like you cannot add new feature very easily, okay? Because like again, like it goes back to the unreusable aspect. Like it's very application specific in nature, and the worst case scenario is like your application has to be rewritten again. Okay, when you have to rewrite the code again, you are going to waste a lot of time, energy, and money. A lot of time is like actually wasted, and not because like you are going to develop the application from scratch, just trying to like figure out like what was going on in the application. So there are like other scenarios as well. Like we'll go into like a little bit more deeper. One of the things is like whenever you are developing the application, like the next time, the first time, like it might take a lot of time, but the next time, like it should not take the same amount of time. It should come down drastically. Okay, that is the main objective of following all the ways. And let's look into the motivation. So now, like we understood the challenges and everything. Now our motivation is longevity of application, so that the application can last faster. For example, one of the example I gave you is like our giants are female. I gave you the example of the the Mars orbiter, okay, from ISRO. So their project is not like develop the application and forget about it. Their project is longer. For example, like they tried like Chandrayaan, like lunar missions and like the Mars missions and everything. And even like the same goes with like a lot of like Large Hadron Collider and all these kind of large projects, and even into the commercial projects as well. Like you cannot actually rewrite the code from scratch. For example, like a LabVIEW itself, you cannot write in a day or in a year itself. So these are the major aspects. Another objective is like you are not going to rewrite the entire code from scratch. It is going to waste a lot of time and energy and money as well. And you want to improve the code reusability, which is going to in turn is going to help longevity of the application. And add functionality without changing existing code. Will come into this one again. It's what we refer as extensibility. Okay, adding new feature. For example, like a LabVIEW is getting new feature each and every time because of its extensibility. Now, flexible and robust code, like it's basically means like it's easier to modify, and then if you want to make some changes, like the application does not break. Okay, it will be like a far more easier to update and modify. Now, like coming back, now what do you mean by the developer experience? Okay. So as a developer, like the main reason why we are into the GLA Summit in Crux is basically like we are trying to improve our developer experience. Because like if you do not know how to do it, then like you will end up into the mess, and you will go into the mess again and again. So like a developer experience is nothing but a metric how easier it is for the developer to code and maintain an application. Okay. It's not what, but like how you have written a code. Because like any person can write a code, like it can do a specific task and like achieve the same functionality, but like the code may not be maintainable. We'll look into that aspect in a moment. Okay. So developer experience can be improved by writing readable code, we discussed already, okay, which are as reusable as possible. And a properly written reusable code will allow the developer develop applications rapidly and supports action. We'll look into this one again. What is the meaning of this one in a moment? So if you want to, how it goes is like it always has to start with the learning experience actually. But most of the time, like people will jump immediately into developing, because like most of the people have this impression that LabVIEW is too easy, or like okay, you just need to develop it. Yes, it is easy. You can develop the application very easily. Like if you just need to like develop some express application, you just need to acquire some data, process it and everything. But if you want to develop larger application, which has to be maintainable for a long time, you have to undergo the learning experience. For example, like all the presentations you are going through throughout this GLA Summit are part of the learning experience. Okay, like how to deal with common problems and everything. And after that comes the user experience finally. Okay, so initially in the beginning, like the user does not really care about like whether you know how to develop it or not, how you develop it. They don't really care. They only care about the results. And if your user experience is better, then like the customer experience is better. That basically means if you are getting the customer complaints coming back and again, times and again, then your customer experience is not good. So the lesser the interaction the customer has with you, the better your user experience. Okay, so that's why like if it comes back with a 5-star, that's good. Like if it doesn't come back or complaints comes, then you are actually doing something bad with the learning experience actually. Okay, and which in turn is going to like impact your developer experience and then user experience and everything. It is a cascading effect and everything. Now, like how to improve your developer experience. Like I said, like a GLA Summit is one of the way to improve your developer experience. That's why like a community is in the bottom. Similarly, you can undertake the education and training from YNI and Alliance partners, as well as our company called Grafitects. And you can use like a libraries, tools, and APIs, which are readily available from like a BI package manager, YNI PM, and so on. So you don't need to rewrite the entire code from scratch. The main objective of DX is not only to develop the application, but to save time and energy. If the reusable code is already available, you don't need to reinvent the wheel, as Jeff Kodosky says. So the next thing is like ease to use and change. These are the things you should be able to modify it very easily. And documentation and support is very, very important. You can find a lot of documentation in the YNI website and everything. I know like in the beginning, like it's a lot of information out there, but like if you persist or you find someone like who already have experience, or you come to this kind of events, you can actually wade it through. Now, like there are certain technical ways of improving developer experience. 3 things. So YNI recommended guidelines, SMOREs. I'm not going to much into this one. And then like we'll go into that one. These 3 are like a more general ways to do it. Design pattern is the 3rd one, which we'll be covering here. So we'll discuss about like why it is so. Okay, why we have to follow this. Now, as you know, like this is a global like LabVIEW Architect Summit, and people are coming from all over the world, speaking different languages from different demographic and everything. And where I stay in Bangalore, like we are actually in the state called Karnataka, which speaks like a Kannada language, and there are like a different states which speaks like a completely different languages. Okay, they have got their own native languages. And even during in this like a GLA summit as well, if we try to present the presentation in our own native languages or the languages that we prefer to use, the communication is impossible. The same goes with the previous slide. YNI recommended guidelines, SMOREs, and design patterns is such that like this is the language you have to use while developing the LabVIEW application. Okay. For example, here we are using English to communicate with each other. Same way, you are going to use these 3 so that like your application is going to develop, like you will be able to develop the application to improve your like developer experience. Now, like we'll look into like the need for design pattern. Okay, so let's say like you have a team of developers, and you got a team of developers, and then like you have given them the task to develop their application. And each of them are going to develop the application independently, okay, without consulting with each other, without discussing anything. They are going to develop the application. And the outcome is like each developer, obviously is able to complete the full functionality. For example, you run the VI or run the application, all of them does the things as expected. Everything works very well. No issue with that one. This is where the user is happy, okay? But the problem is, the challenge is now, each developer uses own unique processes. For example, like some people are like comfortable with object-oriented programming, somebody with a task approach, somebody actor, somebody with like for example, like a code and fix method, prototyping, whatever they know. Okay, some people might be like searching the code from somewhere else and making use of it. Although you have been able to complete the full functionality, still each of them are going to use the different approach. The unique process is neither the standardized nor replicable by others. The issue is now, let's say like there are 3 members in your team. All 3 of them uses their own approach to develop the application. What actually happens is, let's say like one guy leaves the company or goes on a holiday or something like that. Now like the rest of the people have to maintain that code. So in that case, like since it is not standardized, you will not be able to recognize it. That's why like it's very, very important that we use the design pattern. Okay. So what actually are design patterns? Okay. So design patterns are basically like a proven general solutions to common type of problems, okay, which actually enforces you to build the application more scalable, modular, readable, and maintainable. I don't want to go into this one. This is like the technical LabVIEW jargon, which is like simple. You already understand this. But the design pattern will enforce you to develop in such a way so that whatever language you speak, like if you develop the application using the design pattern, another person sitting to the another corner of the world will be able to pick up the code, and then just looking into the design pattern, they can have a hunch. Okay, this application has to execute a certain way. So there are many various different types of design patterns, as you can see. Okay, so I'm not going to go through this one because like We cannot even cover all of this. The ones in the greens are like the Yanai standard design pattern that you can find in the Yanai course material as well as in the Yanai website. And the yellow ones are from the community, for example, JKI state machine, Delacour QMH, and like Q controls. And there are like many others as well. Like these are the part of the LabVIEW champions. So I promoted them as well here. So these are the different types of design patterns. Okay? We'll come into this one. No need to worry about that in a moment. Now the question might arise. Okay, why so many types of design patterns? Okay, why so many types of design patterns? Like because like you have been like some of the people I met, unfortunately, like some of the people I meet while I conduct the training, or like I meet during some of the events, they will come and then say that like their objective is just to deliver the project. But it's fine to develop the project, deliver the project, the customer is happy, your employer is happy. But like when you have to maintain that code, or you you pass that code to somebody else, it actually becomes a pain to that another person. So let's say like I've met like some other people during the training, and then like when they come to my training, they say that, oh, like this is also possible using LabVIEW. Okay? So some people will say that like a state machine is my favorite design pattern. Okay? And I use it in all my applications. Now, like let's say a new requirements comes, okay, because you have a standard like design. So basically, like if new requirements comes, something like this will happen. Okay, you do not know like a word escape. So basically, like if you guys have read a book called like a Book of Five Rings, it's written by one of the samurai from like ancient Japan called Miyamoto Musashi. He was a Zen master as well, meditator, as well as a Buddhist. So he wrote that like you should not have any special fondness for a particular weapon or anything else for that matter. Too much is the same as not enough. Without imitating anyone else, you should have as much weaponry as suits you. For example, like the main objective is like when you are a developer or something, the more design patterns you know, and based on the scenario, you should be using the design pattern that actually suits the particular scenario. Otherwise, like in some cases, it can be overkill, and sometimes like it will not be enough, and like you have to suffer. Not only you have to suffer, your team has to suffer, your customer has to suffer. And most of the time, like in today's like a changing world, what actually happens is developing application rapidly, as you know, like in the Silicon Valley and some of the other parts, like LabVIEW is the like primary way of like a prototyping their applications. Now let's say like you want to taste your product and everything. You have been able to taste your product rapidly and then send it to the market. But the main challenge nowadays is not only to reach to the market, but also to like have the capital, or like capitalize that market for a long time. That basically means you should be able to provide the iteration as quickly as possible. If your code is not like maintainable in such a way, then you'll run into that kind of issues. So that's why like you need to have knowledge of different kind of design patterns. Now the main reason is like one size does not fit all. Okay, for example, like some people say like this is my favorite design pattern. That does not work if you really want to develop your developer experience. So using the design pattern is must. So you have to use a design pattern. That is very, very important. Like I said, like you are going to standardize your code so that like other people who have understanding of the design pattern can understand the flow of your application, how it works and everything. It's easier to understand the application functionality. And another thing is like you just need to understand that like one thing we have to understand that all design patterns are not scalable. Okay, so you need to understand what kind of design pattern you have to use. And just like using the design pattern is good enough, using the wrong design pattern can also impact developer experience. So we'll come into this one in a moment. Okay, we'll look into like a simple case study. So another thing is like the main important thing is you need to select a design pattern based on requirements as well as the future scope of the application. So you develop the application initially. Let's say there is vague idea. Okay, there are like some of the like our customers in Bangalore, based in Bangalore. They are like working on the e-vehicles and everything, and then like they will be developing the application. Now initially like since you are into the R&D, initially like you cannot have the full picture of what is going to happen in the future. So in that case, like you have to follow the architecture or the design pattern in such a way that which is going to highly scalable. It might take a lot of time initially to implement it, learn it, how to use it, but it's worth it. Okay, because like I said, like if you want to make your code more usable and everything, then you have to go with them. And next thing is, the final thing is like a don't overkill with sophisticated design pattern. As you know, like a few years ago, like we're immediately able to eventually able to implement, the actor framework and everything, all that kind of stuff. So like some people will go and then implement each and everything in each and everything. Just like we discussed already, like some people will say that, okay, state machine is my favorite design pattern. Some people will go on using any kind of like a difficult kind of, not difficult per se, but they will be using like some kind of design pattern which may not be can be done with a simple kind of design pattern, okay, without using like a sophisticated. The main reason is we'll look into that scenario as well, okay, because you are not developing the application only for yourself, but you are developing the application for the customers. And then now like if you look into the evolution of the design pattern evolves into something called framework and then goes into architecture. This is the like a normal progression of like a design pattern. So the difference between the design pattern is framework is the only difference is a framework can have one or more design patterns within and also has the APIs. Okay. For example, like what we refer as a QMH and actor, which is very popular nowadays for scalable applications, highly scalable applications. These are basically frameworks. So as you can see, like it's partially complete software that is the moment you start with a template, you can run it immediately. You just need to make changes. I'm not saying like it's completely complete, but you don't have to start from scratch like the design patterns like state machine or Proficiency. Yeah. So if you have any questions, you can like post the question over there. Let's review a little bit, okay? So that like you can have understanding a little bit. Since like we are making use of like since this is a global LabVIEW architect and summit, and then many people are actually joining from all over the place. I try to keep it as basic to like progress forward, and then the strategy, what design pattern you should use, what to decide, and everything. Okay. So if you look into the state machine, this is the like a simplest design pattern. You can think about it. It's polling in nature, which basically means like it runs continually, okay, in particular interval, and has a single loop. One of the example is if you need to acquire certain data or perform some calculation continually, you are going to use a state machine. Okay, but the limitation of this one is like the response depends on the loop speed. For example, let's say like you have a longer delay or a shorter delay. Like the longer delay will cause you to like wait for the next iteration for the application to execute, the next iteration to execute. While if you have a shorter delay, it can use a lot of resources in the system. Okay, that's how like you can miss the user input. For example, if I press stop right now and if I have a delay of like 1 second, then it will not stop immediately. It can take up to maximum of 1 second for that code to execute. The next one is like a state machine event. So this design pattern is like quite popular when you don't want to acquire the data or perform the calculation continually, but you want to perform the calculation or something on demand. Let's say like I press something and then something will happen. In that kind of scenario, I would go with this kind of design pattern. And this is very, very good when the responsiveness is a priority. Okay, and it does not need to run all the time. This kind of design pattern slips continuously. There are many ways to handle different kind of events, which is like out of the scope of this presentation. Okay, the limitation of this is like this is not sequential. For example, let's say like you want to automate certain kind of process one after another and everything. You cannot do with the state machine events, which you can do with the state machine. And you cannot use it for the pulling of the code as well. So this is another limitation. So if I the two scenarios initially, like the state machine and state machine with events, highly useful when you have to use the event and polling separately. Now, like we'll come into like something called producer consumer data. So this is basically a kind of a loop, like a two-loop way. So it is becoming like a little bit more complex. So here, like what it does is like the two different responsibilities. The first one is going to acquire the data or like do certain tasks and provide the instruction for the another loop to process that. Okay, this is very, very useful if you want to like separate the high intensive code with like low intensive code. Okay, for example, if you look into this one, this is from the template, but like you will get an idea. So this loop is going to run continuously all the time in the interval of 125 milliseconds, while the bottom loop will execute only when you want it. Okay, based on like whenever you are going to make use of that MQ element over there. Similarly, like a producer consumer loop is actually with events is very like a very popular and very powerful design pattern, because like it takes the scalability to next level, and you can actually overcome the limitations of both the state machine as well as the state machine with events. Okay, because it can support both the polling code as well as the event type of code together. Okay, and this is like this is going to use a little bit a complex part, something called like a messaging technique, which is being used by queues by sending the comment and data from producer from this loop whenever the event is triggered and passed to the another one. Okay? Again, like this design pattern, like regardless of this one, this design pattern is very useful if you want the user interface not to like run continuously. Okay, you just wait for the user, and only when the user wants the code to run, but you still have the capacity to run this code in like in sequence. Okay, like the state machine. You can make this loop to run as a state machine as well by enqueuing within itself. Now another thing is like producer consumer loop is scalable, although, but like if you want to make it more scalable and everything, you have to create a lot of queues and all that kind of stuff and everything. That is where like Yana had introduced the framework or like a queued message handler, which is actually like a scalable version of the producer consumer loop with events itself. It provides you the template as well as the API. So if you see like there are like messaging APIs and everything, which can be used to like create queues, destroy queues, events and everything. So you can actually like like add as many loops as you can more faster. Okay, but like you can still like reach to this state using the producer consumer loop with events as well. But like this is more scalable because like it is already providing you with some libraries and like some functional code even at the start. Now actor framework, like I think like many of you have already seen this one. We have seen some of the presentations already. So you are going to go with the actor framework when like you have a dynamic number of parallel operations, clones you want it to be executed. So these are the independently running VIs, which are called actors. The main difference between the QMH and actor is like the QMH will always have the fixed number of loops running in the beginning during the comparison time, while actor framework can like create like a multiple instances or the clones of the parallel processes as well. So the extensibility and then scalability is like a very high, and then like this is the highest extensibility and scalability we have seen ever in LabVIEW. So let's look like how we can fix the previous scenarios. So this is what like I would recommend the customers like would come with the code on the left hand side. I would recommend them to use the QMH in this scenario, just like separate the processes and have like a proper communication mechanisms to handle the issues. The next one, I would refer them to use the state machine. Okay, one of the main reason is like although like the code requires only the sequential operation, using the state machine will give you like two benefits. One thing is like it is going to use like a less space, which makes your code more readable. And another thing is like if you want to make some changes or add new functionalities, or let's say you want to split out the processes in the application, you can do so as well very easily. And the third and fourth scenario, like I would suggest them to use the PC or QMH. It's up to them. If you have smaller loops, like you can still go with the PC. But if you are comfortable with the QMH, you can still go with the QMH as well. Okay. So again, like there will be like a slight learning curves will be there. Now, like let's look into the final aspect, final part of this presentation. Like we'll look into the case study. Let's say like a customer comes to you and then asks to develop the application. Okay. So is going to have the setup, and then the the process running process is there, and then stop application. When you press the button, the application is going to stop. So here, like what we're going to do, it is like we'll look into different scenarios when you selected a specific type of design pattern and look into the developer experience. Okay, and developer experience can be like a highly subjective as well, but we'll try to like have a scale. So let's say like we develop the application using state machine. Okay, so when you start with the state machine, if you see here, so for the setup code, like using the state machine, we are polling here for the user to interact with the setup button. Okay, and then like a process, as you can see, the next state is going to handle the process, which is also polling code. And finally, for the stop, like we'll be polling it outside for the stop. So basically, like all the requirements are complete without any issue using the state machine. So limitations, like at least none with respect to the requirements. Okay, all the requirements has been able to be completed using this. The next one is basically using the state machine events. Now let's say we use the different design pattern. Now here what actually happens is like we have actually put the event for the setup, process, and stop command inside this event case. So only when we press this button, we need to process certain kind of like a functionality. For example, if I press the setup, like the setup will happen, and then it will wait for the next event, and then so on. Okay, if I press the stop, then like the stop event will happen, and then loop will stop. But since like the requirement is like our process has to run for t duration, what we did is like when we press the event, we'll go to the another state called process, which will in turn will take us away from the event structure. Okay, it will take us away from the event structure. So it will run for t seconds and then come back into the idle again. Okay. So what actually happens is the limitation here is if you use the state machine events is since all the controls exist into the another case called idle, while the process case is running for t seconds, you will not have access to those controls at that time. It will read the data. Once it will come back, that will even immediately like execute. But at the same time, while the process is running, you will not have access to that button. Okay. So because of this reason, like state machine events in this particular kind of requirement of the application is not like recommended, and like it is going to impact the user experience. Okay. So basically, like it looks like not a good choice. Yeah. So if you look into the producer like a solution using like producer consumable events, I think like I forgot to like change the slide here. So basically, like what actually happens is let's look onto only this side. Okay. So event will wait for the very similar to like state machine events. So like it will wait for the events and everything. But now what actually happens is the top loop will not execute anything. All the responsibility is given to the consumer loop. So all the process will happen in the consumer loop. So it is like a very good in terms of the future extensibility. Okay. The limitations of this is like a none of the respect with the requirements, because produce consumer loop with the events can handle both event as well as the polling code effortlessly. So you will not have any like deficit in terms of like limitations in terms of like requirements covering. But the limitation, another limitation is going to be like you need to do a little bit more programming, or like I need to learn more about like how to implement it. There will be like a certain overhead on like using it, because if you go back like very quickly, okay, if you look into the state machine and everything, if you look here, so in the previous case, like your setup process and everything, process will take place here, while like stop process as well as the setup button events will be handled there. Okay, so this is like the user interface is separated from the processes, so that like this can work as an event, and when you send a single instruction, it will work as an event. When you send a series of like a command from here, or like let's say generated within itself, it can work as a polling code. So this can handle like both of them effortlessly. The only limitation is like it will have slightly more overhead than using the state machine or state machine with events. Now like this is a custom comparison summary for this particular application. Okay, you can like this is like it can be endless. The permutation and combination of like how you want to do it is endless. So here like what you're doing is like we have given like a certain metrics to like a different design pattern and see. Okay, you can also try this out at your workplace and see like which design pattern was favorable with the particular way. Okay, this will the initial task, but after a while like you will gain the intuition on like which design pattern should go with what. Okay, for example here like based on this application which actually had a polling code, so suitability metrics we have given maximum number 5, so this will get 5 out of 5. Easy to learn and implement since this is a single loop, so 5 out of 5. Extensibility not that much, you can add like a new states and everything, but if you want to add like a certain functionality like timeout or panel close or different kind of events or something, then like you cannot have that extensively. But with the current requirements we have implemented, like this is good enough. And relative overhead 0. Okay, because like you don't need to do extra coding or anything. Relative overhead basically means we're comparing this against these two. Okay, so this will be completely depending upon which you are selecting. Now if you look into the state machine events, we saw that we're still be able to complete all the requirements, but while the process was running, like the user interface was not responsive. That's why like it was not good enough, so we gave it 2 out of 5. Next is like ease of learning and it's good enough still, but like I need to learn about event, how it works and everything a little bit more. Actually it's 0 because like it's like the requirement is a polling code while this is an event, and we give like a -2, okay, compared to this one, because we need to use a little bit extra. Now if you look into the produce consumer loop, the functionality suitability will give 5 out of 5. Ease to learn, and it's like a little bit harder than like these two. Okay, more work you have to do. Extensibility is like the maximum. You can add as many features as you can very easily, okay, because it's a multi-loop application. And relative overhead compared to these two is going to max. So we came to the score of this 13, 3, and 7. So we'll go with the state machine. So in this case, like we saw, state machine was a clear winner. So you can also like do this kind of things at your place. So coming into like final slides. So first thing, how to select the pattern is, the first thing is you are going to look after whether it is a single process, multiple process, or multiple asynchronous threads. Okay? So if you have got this kind of stuff, then you can go with the QMS or produce consumer loop with events. If you come single loop, you can go with the state machine events. If you go with this one, you can go with actor, or you can dynamically call VIs, and different kind of approaches you can use. Another kind of thing is like, do you need a polling kind of a code or in demand? This is the another aspects you need to choose. Okay. And another thing to consider, like I say, that if you just develop the application and forget about, no issue about that, but if your code has to be maintained by somebody else, if your project is like a 10 years project or 5-year project, then you have to consider, you have to go into that. Like I said, like a PC, QMS, and actor framework are highly scalable and extensible in nature, but takes overkill, okay, for simple application. So you have to consider that, like whether you want to develop the application that has to maintain it for a long time. And finally, like the final thing to consider is, are you the single developer? If you are a single developer, then you can use whatever you want. There's no restriction up to you, because it's just like learning and breaking down and everything. But if you are working in a team, let's say like you got like a CLA, CLD, CLAD, and everything, but there is a person who does not know like much of a, NI recommended guidelines or design patterns or something. Or there can be the customer base, which you have to deliver the project and everything, but they do not know. Okay, they do not know like this kind of design patterns. So in that case, it's like let's say your customer base does not know anything about the OOP, but they have to maintain that OOP. So in that case, like using the object-oriented programming, like might seem like a good from your side, but like it is going to be an issue afterwards, because the guys, the customers will not be able to use it. So that is why like it is always better to decide design pattern in the beginning. Okay. Now like let's look at the challenges. These are the final few slides, 1 or 2 slides. One thing is like a deadline versus quality of code. I know like everybody faces this one. Let's say you have 3 months of like a target, or like you need to deliver the code quickly. So like whether if you spend time, quality of code will go up and everything. You need to consider. Okay, this is where using the libraries, creating the libraries, reusable code comes to the play. Another thing is the learning curve, like how long it is going to take. The investment requires the time required to learn it. And the next thing, like I discussed, your development team proficiency. All of you, if you have a team of development team, then like you need to be on the same page. Everybody should know like which design pattern they are implementing, and you need to know like how to maintain it. So if you look into the learning curve, where to start and everything, if you look into the time and effort, state machines are easy to pick up and play. Once you master this, you can go to the PC, and then you can go to the QMH, and finally to the actor framework, because actor framework will require you the object-oriented principles and so on. Okay, so these are the different ways like you can proceed. There are certain things you can learn. So the first thing, like I told you about, like the developing proficiency and everything. You can take up the structure training from NI, like CPIs. For example, like a community is also another thing, and you can gain badges from like a NI website as well. Okay. Now the summary. Okay, so I think like we're in dot. We still got some time. So design pattern like enforces the developer to build more scalable. Like I discussed that. The main objective is to standardize the application, and design pattern is a must be selected always. You have to use the design pattern, but you have to select based on the requirements and then the future scope. Okay, and don't try to overkill with the sophisticated design pattern, and never have a favorite design pattern as well, like I discussed already. And consider the development team and maintenance team. Okay, the proficiency level of your team as well as the maintenance team before considering particular design pattern, because what actually happens is initially you might have used the very advanced design pattern and given it to the customers. Now the customers, like you have delivered it, that's fine. But what actually happens is every time the issue comes, they will come back to you. Now, like you will become the point of contact for the customer support, and that is not a good thing, because you should be like solving issues, okay, solving problems of the world, not like a debugging and everything. So it's okay. Now, finally, like we have learned about, you know, a little bit about design patterns and everything, how we can develop the, you know, developer experience. But you have to implement alongside design pattern. You have to follow YANA recommended guidelines as well as the SMORs. Okay, so you can just like follow this, and then this is going to make your life far more easier as the LabVIEW developer, so that you can save your time, money, and energy as well. So these are the references. So we'll be sharing this slide anyways. I think the video is getting recorded. You can make use of this, and you can learn about these things again from the AI website as well as the LabVIEW wiki. And if you have any questions, like you can write to me, or like you can just like you know, put the questions in the chat box. Yeah.
Yeah. So
okay.
I think there's one quick question coming in, and then we'll ask that you move out to the breakout session since we're really
certainly.
close to the
Thank you very much.
time. So Tobias is asking, basically, deadline versus the quality of the code is one main trap or an excuse that people fall into. So yes, how do you escape that? So
in that case, like what you can do it is like you whatever the issues come, like you just like take a log of these issues, what you have faced and everything. For example, like the main objective is like you know, keep your customer coming back. That basically means like a deadline is very important at that time. But there are like a certain parts of the timeline when like the challenges are very less. You don't have too many projects to handle. When you have a like an empty time, you can refactor the code and then like improve the code and start working on the frameworks and create your like reusable libraries. So I would say like you develop the code, for example, like for instance, you're working in certain kind of industry, automotive or something. So basically like a lot of the projects are going to be very, very similar. So in the first point, yeah.
Sorry, I think we're the next speaker needs to get ready for the session. So if you guys could move over to the
I'll take it in the like a breakout area.
Yeah.
Okay. Thank you very much, everyone, for your time. Thank you very much.